This lesson is an application of the rules when we're given coordinate points. So we're getting to apply the rules that we've learned to coordinate points and finding out where those coordinate points end or land when we apply the rule to it. It says, what will be the new position of the given point 3, -5 after a reflection across the y-axis? Well, remember when we go across the y-axis, the y stays the same and the x goes opposite. So it would be still -5 for our y coordinate, but the x would go opposite, so that would be a -3. So -3, -5 would be our answer. Number 2 says, what will be the new position of the given point, -6, 8, after rotating 90 degrees clockwise? Remember when we rotate 90 degrees, the x and the y coordinates change places. So they changed places. There they are. And when we go clockwise, clockwise goes this way. So this coordinate would go opposite. So we have 8, +6 would be our answer, and that's D. Number 3 says, what will be the new position of the given point 7, 4 after translation 2 units left and 3 units up? I know that we've moved things, but this, we don't have the picture to look at, so we have to consider how the numbers change when we apply the translation. Remember, left and right is our x coordinate, and when we go left, we're going in the negative direction, so we subtract. So this would be 7 - 2. 4 units up would be in a positive direction, so we'd be adding 4. And so 7 - 2 would be 5. And 4 + 4 would be 8. And 5, 8 would be our answer. Number 4 says, what will be the new position of the given point, -2, -3, after a reflection across the x-axis? So remember, when we reflect across the x-axis, the x coordinate stays the same and the y goes opposite. So this would be -2, +3 that we would be looking for. And I left you 5, 6, 7, and 8 on this page to do. And we may have some new things that we run across in this, if I'm remembering right. What will be the new position of the given point, -2, 6, after translation 5 units to the right, 3 units down? Well, the right would be going in the positive direction, so we'd be adding 5. 3 units down would be subtracting 3. -5 + 2 is the same thing as 5 - 2, which is 3. 6 - 3 is also 3, and A is our answer. So number 2 says, what will be the new position of the given point, 5, 7, after a reflection across the line y -1? So this is a little something different. Now, we're used to reflecting across the x or the y coordinate. And this is giving us something just a little bit more challenging. If we have a coordinate grid, like we're used to, we have our x-axis and our y-axis. The line y is equal to -1 is at where y is equal to -1. This would be our line. I'm just going to make a dotted line so we'll know where it's at. Okay, so that's y is equal to -1. And we're going to reflect this point across it. Remember, it would end up in the same spot on the opposite side of our line. Now, if we reflect it across the x-axis, that looks pretty similar to that, isn't it? That looks very similar. It's only 1 unit away. If we reflect across the x-axis, our x-coordinate would stay the same. If we reflect across this line, it's right next to the x-axis. Our x-coordinate's still going to stay the same for the same reason that it does when we reflect across the x-axis. So our point 57 is 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6, 7. So I would say it's about right there. We're going to label it 5, 7. Now, if we take this point and move it down, our x-coordinate for that point is still going to be a 5. So the x would stay the same. The y would be opposite because these coordinates down here are going to change. So we reflected it, we took it and put it on the other side to get from this point to the y -1, we would have to go down. Well, x's don't move down. X's move left and right. Y's go up and down. So to get from 7 to -1, we'd have to go down 8 spaces. So we went down -8. And then we'd have to go down from this point, we'd have to go down another 8 points. So from -1 -8, we would stop at -9. So our new point, my x-coordinate is still going to be 5. The x for this point is still going to be 5. The x doesn't change. But the new coordinate for this would be, oops, sorry, it doesn't want to write, -9. So our point is 5, -9. And that's something that we haven't done before, but that's okay. What will be the new position of the given point -1, -3 after rotating 180 degrees about the origin? Remember, when we rotate 180 degrees, it's the same thing as turning completely around. When we turn 90 degrees, our x and y coordinates switch places. But when we go 180 degrees, they do not. So our x and y will stay the same, but their signs will both go opposite. Well, in this case, they're both negative, so they'll both go positive. So this is +1, +3, and that is the letter D. So number 4 says, what would be the new position of -6, 0 after a reflection across the line x is equal to 2? Okay, well, this is very similar to what we just did. This time we don't have y is equal to something, we have x is equal to something. And x is equal to 2 would be right here. So our line for x is equal to 2 would be parallel to the y-axis. So in other words, what I'm telling you is the y-coordinate is going to stay the same. Well, the y-coordinate in this case is 0. It's going to stay the same. And our x is going to go opposite. So if we had our point at -6, 0, so -1, -2, -3, -4, -5, and we're going to say that this is -6, 0. And we reflect it across this line at 2, that's 6 to 0, and then 2 more would be 8 spaces. So to land in the same spot on the other side of the line, we'd have to go 8 spaces further, and 2 plus 8 is 10. So our coordinate point for that would be x is equal to 10 and y is equal to 0. So that's very similar to what we did. So this is it's a little something new that we're learning today, which is not too difficult, but it is new. And I'm leaving you 5, 6, 7, and 8 to do. And we're on the third page. What will be the new position of the given point 6, -5 after rotating 90 degrees counterclockwise? Remember, when we rotate 90 degrees, the x and y coordinates switch places. So I'm going to put my -5 here and my 6 here. They switched places, and counterclockwise goes this way. So that means this coordinate will go opposite. So it is a -5. Now it's a +5. So C would be my answer. Number 2, what will be the new position of the given point 0, 1 after translation of 2 units to the right, 6 units up? So x goes left and right, and when we go to the right, we add. So this is 0 plus 2. 6 units up. When we go up, we add. So this will come to 2, 7, and they're both positive, and A would be my answer. What will be the new position of the given point -8, 4 after a reflection across the line y is equal to 2? Okay, well, here's another one of these that we are practicing. Sorry, that's not a very straight line. Y is equal to 2 is at this place right here. This is the graph of the line y is equal to 2. Okay, and we are reflecting this point across. Remember, when we reflect across the x-axis is parallel to this. So when we reflect across the x-axis, the x stays the same and the y goes opposite. So in this case, because those are parallel lines, the x is going to stay the same. So we know this is going to stay the same, which narrows down our answer choices quite a bit. And we are reflecting it across. It has to land in the same spot. So let's see where a -8, 4 would be. So I would say 1, 2, 3, 4, 5, 6, 7, 8, -8, +4, 1, 2. So I would say about right here. That would be our point. And we are reflecting it across the line y2. So it's going to have to end in the same spot that on the other side, the same distance from this. Well, it is 2 spaces away from this, so it would have to land 2 spaces away from this line, and 2 spaces away on the other side of it would be at 0. So our x stays the same, it would be -8, and our y is 0. So here's our number 4. What would be the new position of the given point, -7, -9, after rotating 180 degrees? Remember, when we rotate 180 degrees, the x and the y stay the same. They don't switch places, but their signs go opposite. Well, these are both negative, so they'll both go positive, and +7, 9 would be our answer. I'm looking at number 6, and I think I'm going to go ahead and do number 6 with you because it is a little different. And I know that you've done a slope of -1 before. But sometimes when we're doing these types of things, you're not thinking along the line that that negative in front of that x is actually the slope. That's a slope of -1. In other words, it goes downhill. It's a proportional graph. It will go through 0 because it doesn't have a y-intercept. It will go down 1 and to the right 1. So this is what the line y is equal to -x looks like. It starts at 0, it goes down 1, it goes over 1. It goes down 1, it goes over 1. It goes down 1, it goes over 1. So it's just a line that goes through the graph similar to this. Okay, so let's see what happens. What will be the new position of a given point, 5, -6, after reflecting across the line, y is equal to -x? Well, let's see where 5, -6 would be. So 5 would be 1, 2, 3, 4. Well, we need another dot, don't we? 5. And when we go -6, see where that would be. This would be -1. This would be -2. This would be -3. This would be -4. This would be -5. So -6 would be down here. And that would be 5, -6. I think I'm going to make that red so we'll know that's different than my little dots for my line. This is my line. I think I will make it a little bit better so that we could see where that is. Okay, so that's the line we're reflecting it across. When you reflect something across a line, it's a mirror image, so it goes on the other side of that line. So if this was the mirror, our 5, -6 would end up in the same spot on the other side of the mirror. So it would end up about right here. Uh-oh, sorry, I didn't get a pen. Oh, I did right. Okay. So let's see what that spot would be. This is 5, so that would be 6. My x would be 6, and my y would be negative 5. It's not going to let me write there. So 6, negative 5. Get my pen. So sometimes we have to go ahead and graph something to see what's actually going to happen when we reflect it. And it does help to count your spaces and think very carefully about what you're doing when you're reflecting something. Okay, so I'm going to minimize this, take us back, and I do want to go ahead and check and make sure there's anything else that I don't want to leave for you. Number 7, I am going to go ahead and draw number 7 for you. It's 7, 1 across the line y is equal to x. Remember, that's the slope of 1. This is what they're talking about. If you have a slope of 1, it rises 1, runs 1, and it kind of looks exactly like that. So if you'll use this little graph, it might help you. And you are reflecting 7, 1. And so what you need to do is map out 7, 1 on this little grid, or if you want to draw one on your own, that would be okay. And find out what happens when you reflect 7, 1 over the y is equal to x line. Okay, the rest should be just fine. And I will let you go ahead and finish that up.